Hello, everyone. Welcome to tonight's latest webinar. That's so exciting. We've got you all here to the Eclipse 2024 Sunblock, Scorpions, and Double Diamond Rings. Moderator Dr. Janine Fisher, and our two presenters this evening, Dr. Lika Guhathakurta and Dave Jones. Before we begin today, I just want to address some of the guidelines for the webinar tonight. If you have questions, and there's going to be a lot of great things that we're going to be covering, if you have questions, just feel free to put them in the Q&A at the bottom of your screen throughout the webinar, and we will be getting to them when we can. So feel free to put in when you have a question. We'll have some specific time for answering those questions when we're able to. There's going to be a lot we're going to be covering tonight. I'd like to introduce tonight's moderator, Dr. Janine Fisher, who's a program scientist in the NASA Heliophysics Space Weather Program and a valued member of the AMS Weather Band Committee. Dr. Fisher's experience and connections have been instrumental in organizing this webinar tonight. So Janine, thank you very much for joining us.
Great, thank you so much. And I am very happy to introduce our presenters for today for this exciting webinar. First, I'm going to introduce Dave Jones, who is a weather industry veteran and the CEO of Storm Center Communications, Inc., which developed GeoCollaborate. And you will see GeoCollaborate demonstrated during this webinar, which is going to be pretty cool. And the White House and SBA awarded GeoCollaborate the Tibbetts Award as one of the most innovative technologies in America. Dave also co-chairs the ESIP Wildfire and Disaster Life Cycle Clusters, is a member of NOAA's Extreme Events Ocean Observing Task Team, and was just recently presented with the Laureate Award from the ICE Association in recognition of his outstanding contributions to observing, understanding, and protection of our oceans and coasts through vision, leadership, friendship, and collaboration. Our next speaker will be Lika Guhathakurta, who has led the development of heliophysics as an integrated scientific discipline from which fundamental discoveries about our universe provide direct societal benefits. She made possible the flagship missions, for example, Solar Dynamics Observatory, the Van Allen Probe's Solar Orbiter Collaboration, and Parker Solar Probe, including stereo, that would revolutionize our understanding of how the sun shapes space weather in the solar system. Since 2017, she has been the driving force at NASA headquarters and at NASA Ames behind the growth of Frontier Development Laboratory, both in terms of the breadth of problem areas tackled, as well as in the number of agency and industry partners. Lika is presently a senior advisor for new initiatives at Goddard Space Flight Center and a program scientist at NASA headquarters Heliophysics Division. So welcome both. And now I'd like to turn it over to both of you, Dave and Lika.
Great, thank you, Janine. I just I love that background that Lika has right now. It looks like she's always coming up with a great idea. It's very illuminating. So welcome everybody.
Well, my hair is blending into that.
It's perfect. It's perfect. I hope that you have as much fun, all of you attending the webinar, as Lika and I are going to have tonight. We're going to keep it very informal. We hope all of the cool visuals work. We know that when you spend a day setting things up, something is bound to happen, of course. But welcome everyone to this evening's webinar on the eclipse. For those of you that haven't heard, there is going to be an eclipse on April 8th. That is on Monday coming up, so less than a week away. And the shadow of the moon will cut across, and I'm going to share my screen here. There we go. The shadow of the moon is going to cut across Mexico, the United States, and Canada. This is a high-resolution NASA visualization. There it is, making landfall in Mazatlan, coming across Texas, and then through the Midwest. There are about 200 to 230 million people that live within a 2-hour to 2.5-hour drive of that path of totality. And it's really quite spectacular. So this eclipse is going to happen. I'm joined tonight by an extraordinary heliophysicist, And I'm going to put up our PowerPoint slides here. This is what we use to help people get excited about it. This in the background is Bandera, Texas. That's where we're going to be. We'll talk about that soon. But I've heard Dr. Lika, and that's what we like to call her, not a heliophysicist, but I've heard her been called a heliophysicist. And I'd say the heliophysicist, because I think, Lika, your awesome accomplishments in the field of space sciences are just incredible. I mean, Lika has done lots of stuff we're going to talk about, but Dr. Madhulika Guhathakurta, or Lika, welcome to the AMS Weather Band podcast, video podcast. And are you ready to talk about some fun stuff tonight?
I'm ready. Now that I'm hearing about it, I think there should have been some background music. But thank you, Janine, and thank you, Dave. Extraordinary or not, as an ordinary individual, I have had quite a bit of fun kind of working and shaping this field. And yes, I am. The only thing I take credit for is that I am the heliophysicist, because I myself, with my son and his fiancée, essentially coined this word about 4 years ago, and we loved it. It was an instant winner. So what is a heliophysicist? It's a space where science and art converge. The name itself is a playful fusion of she and heliophysics, right? Embodies the idea of me and us within the heliocentric world. I mean, there's just a lot of play on words here, right? But this is not just about STEM, which we hear a lot. It's about embracing STEAM, this whole idea, the concept, science, technology, engineering, arts, and mathematics, to blend the analytical with the artistic, integrating poetry, music into the vast canvas of understanding the sun, to delve into the realm of heliophysics. Heliophysics is a tough word otherwise. We have to blend all of this, give it shape, and then deciphering the profound impact of the sun on our lives and exploration of space itself. So I'd say, as we prepare to embark on this, let's call it celestial exploration, the human species, we're going to uncover how our existence is really intricately woven into the sun and sun's outer atmosphere. We live with this star. From the dance of solar storms that you will see, some from our satellite imagery, to the interplay of cosmic forces, which you cannot see. These are the magnetic forces, will unravel the mysteries that surround us. So that's heliophysics.
That is awesome. I don't know about you, but I could sit back and listen to Lika talk all evening about all of her knowledge of the universe and the sun. I'm going to take a little step back. And for those of you folks that are looking for me talking, I'm projecting my screen, so you won't see me talking, which is just fine. But I'd like to start back a little bit, because Lika and I have known each other for many years. And I had the pleasure of being with Lika in 2017 first. Remember this, Lika? In Breckenridge, Colorado, at the Glenn Gerberg Weather and Climate Summit, when we had the last total solar eclipse that traveled across the U.S. from Oregon to South Carolina. We were very, very busy that day. Lika was on a panel discussion. You can see her there in the lower right, and engaging with residences. We had a town hall meeting where we invited the residences of Breckenridge to come in, and boy, did they. And it was really fascinating. And here's Lika. Any of you weather nerds recognize this gentleman to the right of Lika, to the left of your screen, Dr. Howie Bluestein, who is a preeminent tornado researcher from University of Oklahoma. A terrific, terrific guy. And Lika is just expounding upon the eclipse and what it means to us. Meanwhile, outside, we were getting 3 or 4 inches of snow an hour, I think. That was pretty amazing. And then in August of 2017, we went to Salem, Oregon. And in Oregon, we set up at the Oregon State Fairgrounds there in Salem. We had a satellite truck. That's that behemoth behind us. And this was our crew, where we put together stories and we put together live coverage. We worked with Veronica Johnson, who is the chief meteorologist now at ABC7 in Washington, D.C. She did a live show for several hours, and Lika was one of the guests during that show. So it was terrific. We made that happen. Now, for me, it was my first experience of totality, going to the path of totality. I was excited about it. I hadn't experienced it before. I was like, okay, it's going to be kind of cool. But after talking to Lika, it's like, boy, I better be ready for it. And this was one of the shots that we took, and it was just spectacular. So I have been to one total solar eclipse. I am heading soon to Texas to see the second one. And Lika, I'm just wondering, how many eclipses have you seen over your career?
Well, that would be, let's see, like a dozen. Starting in 19. This is so my start with eclipse is not actual sight observation of eclipse. The first time I saw total solar eclipse is in 1991 from La Paz, Mexico. This is July, and this was the longest eclipse I had seen, close to 7 minutes. And follow on to that, I have seen 11 more, and I'd like to talk a little bit more about that. But before, I actually start with the 91 eclipse, which is something I went to see just as an amateur with my family in Mexico. I'd like to say my brush with eclipse, that's kind of at the very center of my career, my relationship with the sun and heliophysics itself. So when I went to school, graduate school, heliophysics wasn't a discipline, right? And I basically studied astrophysics. It wasn't until at the, when I did my graduate school in solar physics from High Altitude Observatory, National Center for Atmospheric Research, where my deep connection with solar physics and solar corona began. I mean, there's got to be a start, life is a cycle too. There's got to be a start of how did I even get introduced to this amazing field. And then from there, I went to University of Colorado and did instrumentation, rocket launching, all of that. And the fun story here, and maybe Dave, you have a picture of this, is the first diagram picture of my thesis is actually it appeared in Time magazine in 1989. It is a combination, first of its kind, of the white light corona that many of you will see if the sky is clear and you're in the path of totality. And this white light image was taken from HAO, And in the center, what you're seeing is sort of near simultaneous observation taken by LASP, Colorado University, where I worked as a research faculty, which looked at the sun in soft X-ray. And so this was the first time we had produced a composite of what's happening on the dark face of the sun when we are seeing these structures in the corona. And my thesis was actually kind of studying the large and small scale density structure in the corona. So this was a very novel kind of composite that happened for the first time that Time Magazine bothered to put it up. And today, such kind of pictures are dime a dozen. NASA is taking observations of the sun in different wavelength continuously, basically. So I just wanted to end it there and go back, because this is my start in 1988 with the eclipse, even though I didn't see it, but I studied it intimately. And so going back to sorry, Dave, you had a question?
No, I was just going to say, it sounds like you've traveled already in your career thousands and tens of thousands of miles around the globe to see total solar eclipses.
That's for sure. If you're asking for how many miles is that, well, I don't have an exact number, but let's think of it this way. The cities that I have lived in America, they're kind of on a latitude 40 degrees, Boulder, then Washington, D.C., and San Francisco, serviced by United. And let me tell you, I am a United 2 million miler. That's about 4 round trips to the moon.
You have any companion passes?
I do. One.
Oh, goodness.
That goes to my husband.
Well, what are we seeing here? It looks like Zambia, and it looks like South Africa.
This is Zambia, 2001. Yes, this is so, the prior eclipses after 91 was in 95 in India, very, very short. Then, so I had some brushes with eclipses and observations. 97 was in Caribbean, 98 in Mongolia, extraordinary eclipse. Then Turkey, 99. Then this is Lusaka, Zambia. In fact, after our eclipse observations here, Zambia sort of didn't even remain as Zambia. It's kind. I have these notes and all sorts of things. What happens to places, cultures, countries you visit when you visit them for eclipse, and you come away and it just gets transformed. In fact, that what you are seeing there, that picture. So we had a campsite that was barricaded by electric fencing, because we were actually deep in the jungle, and there was a water hole, where animals would come in the morning to drink water, so we could see them. And that little structure you see, that's where we had our eclipse set up. It was every eclipse trip, has been absolutely amazing, both from the people and culture perspective, and just studying the sun. Oh my God! Look at that. That is a fresh kill. A young zebra killed by a lion and hung up on a treetop so that no one else would have access to it, so that the lion could come back when it felt hungry again. There are sights I have seen. It's just amazing. So I don't know. You get me started on eclipse journey, I can talk forever. This is Antarctica. This was in 2021, December. We did not actually get to see the eclipse here. There was a major storm blowing. But what we saw, the effect of a major storm covering the sun during an eclipse, has its own kind of light. Very, very interesting. But because we are talking about eclipses and so many eclipses, and because there is sort of a connection here between, I think, my life and eclipses, is that I'd like to share an eclipse story with you. So, there's a period of time, just about under 19 years, between successive lunar or solar eclipses, basically, right? Occurring when sun, earth, and moon are in the same positions relative to one another. Same position meaning, if the moon was in perigee, then it's going to be the same in the Saros cycle, for example. And the cycle is known as Saros. And the Saros sort of came from a description from an ancient astronomer named Sudas about 3,600 years ago, who said that the length of the Saros cycle is about approximately 19 years. Now, it is possible to predict, many other kind of eclipses using the concept of eclipse cycles. But the Saros is probably the best known and one of the most accurate ones. So my life in 1988, when I started kind of really getting absorbed in that 1988 eclipse and the solar corona, that was Saros 139 eclipse. And so lo and behold, in 2006 came the Libyan eclipse. And the Libyan eclipse is, you probably have some interesting pictures of, Libyan eclipse. So the Libyan eclipse happened, we couldn't go to Libya in 2006. The Libyan government actually invited NASA scientists as well as international researchers to a conference that was held along the path of totality in the deep Sahara Desert, very close to Chad border. This was an international conference, and it was absolutely remarkable experience of how science essentially transcends language and borders. And it's not just words, it actually happened. And a relatively rare phenomenon like a total solar eclipse can provide opportunity to bring together researchers from different cultures. And NASA actually took this opportunity and sent 2 film crew with us and public affairs officer and sponsored a film. It was called, it's still there, Path of Totality, US-Libya Science Cooperation. And that was released in 2007. So that is Saros 139 also, 18 years later. And what's coming up in 2024? That is the next Saros 139 eclipse. So it just seems like, it's not just eclipses that have cycles. I mean, human life, human careers kind of also sometimes have their own cycle. And for me, I guess it's Saros 139.
That's amazing. I think we have a couple of questions, and I thought that we would do the webinar more interactively today. And so, Janine, I think you've looked at a couple of questions. What you got for us?
Yeah, so Lika, a couple questions have come in for you. Some are a little more personal, some are more scientific. Let me start with this one. Did anything surprise you about the first image that you've seen of the sun?
You mean the 1991?
I think when you described that the first time, your first image.
Yes.
Yeah.
Oh my, the first time. I mean, I studied eclipses, right? 1988, but 1991, when we got dropped off on the beach of La Paz in Mexico, and the solar eclipse is happening. Remember that solar eclipse, 1991, is very much like what we are going to experience in 2024 in terms of the activity level. It was peak solar max. And you could, I just looked in awe. So what struck me, because I studied eclipses on the computer screen, is, oh my God, it's not as big and large in the sky as I thought it would be. Then it's the color of the eclipse is just mesmerizing. It is a pearly halo light that we can't produce here on Earth. The other thing was you could actually see the dynamics with naked eyes. So we had binoculars. So you look at the eclipse only during totality. So do not look at the eclipse with binoculars, please. And I could see post-flare loops, actual activity. And then it was finished. And at that point, I had no idea that I am seeing the longest eclipse ever in my life. Those are my thoughts.
Yeah, great. Thanks, Lika. Let me try another question here. And you probably get this a lot. How often does a total solar eclipse occur anywhere on Earth?
So total solar eclipses occur at a rate of between 12 to 18 months, more closer to sort of 18 months. And they happen often over water, just because most of Earth is water. And so it can happen. And that's why we are so lucky, right? Because this is happening over this long stretch of land where people have easy access to go see the total solar eclipse.
You know, Lika, this reminds me of one of the videos that we have. I'd love to show everybody, and that is the video of the Wyoming time lapse of the eclipse happening. How about we take a look at that?
Sure.
So this, as you watch closely on your computer screens, look at it getting darker. This is a time lapse in 27.
So this is an amazing sort of capture with a drone, capturing the shadow of the moon. Is this playing, Dave?
It is.
Okay, it seems it takes few minutes, but you will see the changing color. And so these were captured by citizen scientists. It gives you a 360 virtual reality eclipse experience, showing the moon's shadow literally sweeping across the Grand Teton mountain range. And so when you see this, there's this like vast palpable shadow seems sort of overwhelming the world. That's kind of what you see. And the blue sky, incredible. You saw, right, changes to gray.
I'm going to play it one more time.
And then purple play. Yeah. Because it's just amazing. Just pay attention. And then you can see how speedily it becomes very, very dark and ominous. I mean, this is a momentous, unique experience. And, over a period of less than an hour, basically all this is happening, right? And it gets 10,000 times darker in the last minute. I mean, that's the difference between, the sun sets every day, right? What's the difference between a total solar eclipse and when the sun sets,
right?
Basically.
The sun touches the peaks of the mountains again as it comes out and emerges and then spreads throughout the valley is just spectacular. Wow.
Yeah, this is awesome.
We have that one. And when we were in Salem, Oregon,
yes.
we set up a time-lapse camera. And you'll be able to see, this is the clock tower animation that we call it. And the eclipse totality was, you can see the clock there and you can see the cars moving back and forth on the highway. But the eclipse happened at about 10:14. So you see the arms of the clock moving around, and you'll see it start to get dark from behind us because we're looking to the east, and the eclipse is approaching us from the west. And watch what happens.
It gets pretty dark.
And this will happen too. If any of you live in the path of totality, when it gets dark, just listen to what happens. You might have bugs that start to chirp because they think it's dark. Look at that. That is 100% totality. And look at this. It's a time lapse. And it's over just as fast as it started. It lasted about 2 minutes and 40 seconds in Portland or in Salem, Oregon.
Something else to kind of remind our listeners, something else to look for. You might not have the landscape of a mountain or whatever, but you can always do wherever you are. It's kind of interesting to do this time-lapse movie. But one thing you should pay attention to, so typically Eclipse path is about, between 17 to 100 miles wide, right? And so if you're at the center of the totality, that path, so maybe you are 35 miles away from each sort of horizon. So the shadow is in that band, moon's shadow, right? But outside of that, there is still sunlight. So if you are kind of in an open space, you can actually see 360 degrees sunset. There are lots of things to watch out for, sounds of animals, all different kinds, some waking up because they are nocturnal and some going to roost because they think that night has come.
It's really amazing. It really is. So I was going to ask Lika, I know that everybody gets excited about an eclipse. There are many people that are probably watching us here right now that have never seen an eclipse before. I see Janine, so she probably has another question. So let's take that in, and then I want you, Lika, to also think about what excites you the most about the upcoming eclipse that we'll be able to experience in Texas. And by the way, Lika's going to Texas. I'm going with my team to Texas. We're going to converge in Bandera, and we'll talk about that in just a little bit. Janine?
Yeah, thanks, Dave. I actually saw two questions that were related to something that Lika just said. So the first was, and Lika, you were talking about sort of the difference in time lens. And so one question here was, let's see, you mentioned your first totality lasted 7 minutes, and then in some places it could just be like 4 minutes, right? And could you comment a little bit about what accounts for the differences in the lens?
Yes. So, in fact, we have Eclipse map that we are going to show to address this question. When Dave shows the map, I will talk about it. So let me answer it at that point.
Yeah, we can do that right now if you want to, because we are very flexible here.
Yeah, why not? Yeah.
We want to be very responsive to everybody's. Okay, here we go. This is the path of totality as on April 8th, as the shadow approaches Mazatlan in Mexico.
And so can you pause there just for a second?
Yes.
And so I am not forgetting the question. I will answer it at the end of this journey, but I kind of want to pick spots as we are showing this path of totality. So Mazatlan is from where we are going to launch some NASA airplane, WP-57, where we have 3 experiments, both looking at the solar corona with wavelength that is not accessible from the ground. And we also have the first time flying ionosun, which is like a radar measuring radio waves being reflected by the ionosphere to understand how the ionosphere is changing because of the cutoff of radiation from the sun. So we have 3 experiments that's going to start at Mazatlan. These are the high altitude plane. The planes are going to fly at 50,000 feet. And so, the weather forecast, I guess Dave will show us something through GeoCollaborate later. But even we ordinary people can look up, and it's not looking great everywhere. But one way to ensure that we get the observations that we are seeking, because eclipses make for conditions that allow certain observations. That's not possible any other way, not through satellites or not through ground without Eclipse. So flying at 50,000 feet, you're already sort of above the cloud bank, and the seeing conditions is very clear. So your observations are fantastic, and you have access to different region of the electromagnetic spectrum that you don't from the ground. Also, these jet planes are traveling at a pretty high speed, 460, 470 miles per hour. So what it does is it's actually also lengthens the time of the eclipse. So if you're on the ground, you're going to see the eclipse for 4.5 minutes, say at Mazatlan. But if you are at that height, traveling that fast, you can add another 2 minutes. So that kind of adds to the amount of observations. So
love this picture here.
Please continue with the movie. Yeah.
This picture here is of a NASA WB-57 crossing the eclipse in 2017 in Macadana, Illinois. Courtesy of
That's amazing.
What a spectacular picture.
Kelvin Helmholtz instability, you're seeing the smoke trail. It's gorgeous.
It's just a wonderful.
To be unnerved.
Let's continue along the path here so we can let everybody else know what's going on. So let me see here. I'm going to start it up. There we go. So we continue from Mazatlan and go across Mexico through Durango. This animation is put together by NASA's Scientific Visualization Studio using the night lights underneath. So you can see where it does get dark. That's where these lights are probably going to turn on, and you may not want to be near any lights when you're watching. And so, whoops, I passed Eagle Pass. Now look what we can do.
But you can pause and we can just talk right there. Eagle Pass is right there. So this is really cool. So we are flying, WB-57 with instrument. We are flying low-tech kite carrying a spectrometer. This is the second time again, the kite we would have flown a spectrometer. This was demonstrated at the eclipse of 2023 from Exmouth, Australia. Now imagine it's the same principle, right? Because anytime, if you're an eclipse chaser, if you depend on eclipse observations to do your science, to enhance our science in heliophysics, then you have to really cut short almost 50-50 chance you have of seeing an eclipse or not, because it could be cloudy, because it depends on weather. But if you can go higher up in the atmosphere, then you don't care about the cloud. So this is something that's happening from Eagle Pass. Okay.
We're going to continue from Eagle Pass, and we're going to go to into Texas, because Eagle Pass is actually where the border of Texas is, and it goes right across through Uvalde, and that's where we're going to be in Bandera, Texas, which is northwest of San Antonio, and we're going to have four telescopes set up in conjunction with Rice University and the Houston Museum of Natural Science. Thank you both to those organizations, and we're going to be streaming that video live, so you'll be able to see it as well. And the path continues into Arkansas and through Hot Springs, through Mountain View and Batesville, up through southeast Missouri, through Cape Girardeau, Carbondale. Whoa, Carbondale! Come on,
you have to, yes. And before you start at Carbondale, I want to kind of point out that if you go to the NASA Eclipse website, we have, and I think Dave, your Geo Collaborate will also show the number of sunspots, special centers we have for really addressing the needs for this eclipse along the path of totality. But Carbondale is special, so please.
Absolutely. And so in Carbondale, let me just give you a little. In 2017, the eclipse passed right over Carbondale, and in 2024, the eclipse path intersects Carbondale as well. So they've been very busy at Southern Illinois University. And I just want to give you a little overview of what they're going to be doing with the dynamic broadcast initiative for the eclipse. Dynamic Eclipse Broadcast Initiative.
The Dynamic Eclipse Broadcast Initiative, which we also call the DEBA Initiative, is a network of telescopes all across North America, and they're volunteer operated. We're using standardized astrophotography software and what essentially is a standardized astrophotography setup. Small telescope, small camera attached to it, and a laptop collecting the data. So we'll have 75 observation teams throughout the US, Mexico, and Canada. And we're looking during the total solar eclipse for that evolution of the corona as we look at the eclipse along the entire path of totality. And we're also looking outside of the path of totality at the solar disk to be able to connect the changes that we see in the solar corona back to the surface of the sun. So we get images all along the path of totality and outside the path of totality, and we can put those images together in a movie. Each site makes a frame as we see the corona evolve during the total solar eclipse. This is outreach in a big way. We expect to have close to 300 volunteers on these teams doing the observations. And those groups pull in other people that are interested in it as well. A project like this enables them to see how they fit into science projects, how they can contribute to it.
And that's part of NASA's heliophysics big year. We'll talk about that a little bit as well. But I want to continue the animation too. Would you, Lika?
So, yeah, can I actually pause at this point before we go to answering the question at the end of this journey? Is something about the creation of these maps and the shadows. So, one of the questions you had asked me earlier, I think, is what excites me most about this eclipse, right?
Mm-hmm.
And there are many things, and I'm not going to that. But one thing that's special about observing the eclipse from the Bandera region is that there is a possibility of seeing double diamond ring. So remember, kind of the description of our talk was sunblock. We are only talking about that. That's the eclipse, double diamond ring. And I want to talk about that and how kind of observations of the moon makes it possible. And then, of course, scorpion, I mean, if you are in the desert somewhere, they are around, so be careful. So now,
I do not like scorpions.
What happens? Well, depends. They are a little scary. They are. And, people used to be scared about eclipses too, when they didn't know what eclipses meant. But I really want to home in on how all of these things are possible, right? How do we have such incredible maps? I think compared to any planet, including our own, or satellites of our planets, we have the most accurate, high-resolution topographical map of the moon from Lunar Reconnaissance Orbiter, LRO. It's absolutely amazing. So so how does this happen, right? When totality approaches, the low-lying valleys on the moon's edge still allow some sunlight through, forming these bright spots of light called Bailey's beads. I'm sure you have heard this and you can see them. People love to capture them. And the last of the sunlight streaming through the moon's valley creates a single bright spot, a flash of light. And this is known as the diamond ring effect. And it makes for literally there's this thin crescent around and this flash. Now, typically, from a given spot, we only see one diamond ring, and a diamond ring ushers that totality is coming. When that last flash disappears, you're immersed in totality, and out comes the corona out of nowhere. I mean, it's breathtaking when you see that. Now, this particular spot in Bandera, because we know the lunar topography so well, it's safe from calculations that it has the potential to show two diamond rings that Dave just showed. I have never seen one, and that would be absolutely cool.
That would be very cool. One of the things I wanted to point out when we were looking at this animation, and it's frozen here, is that you can see the 4 minute of totality timeline getting narrower and narrower, and it disappears right to the east of Indianapolis. And I'll take this backwards a little bit. You see where that little area ends in Indiana, right before Ohio. That is where the eclipse totality stops being 4 minutes long. And it's because in the upper right-hand corner of this animation, you can see the moon distance. The moon's distance from the Earth is getting larger. I'll put this into play and just look at that number in the upper right-hand corner, moon distance. It's getting further and further away from the Earth. So the path is getting narrower and the length of totality is getting shorter. So as this passes up through Rochester and Buffalo and into Vermont and New Hampshire and Maine, look how elongated the shadow gets. And look at the 3 minute of totality line starts to narrow and end as it gets in over to the Canadian Maritimes.
So remember, so this is sort of beginning to answer the question, right? Why do we have different timeline for eclipses? Why are some eclipses, close to 7 minutes, some 2 minutes, and even along the path of totality, they change because the distance of the moon is changing. The closer the moon is to Earth, we are seeing a bigger, essentially angular diameter, and it's covering the sun more. And as it's going around, the time frame, as the time goes on, it's moving around its orbit, and that distance changes. And you are actually getting a different kind of angular view of the moon, and therefore the shadow, and therefore the amount of time that a totality will occur. In fact, what's something we don't think about very often is that, moon is actually gradually, moon's orbit is increasing by about 1.5 inches per year. And in 600 million years, the moon will be far enough from the Earth that we will never, ever be able to see a total solar eclipse again. It's kind of sad, but it's 600 million years. So don't worry too much.
Okay, everybody, you heard that from Dr. Lika. So you want to get out, and remember, we're talking about the path of totality here, but everyone in the lower 48 states is going to experience a partial solar eclipse. So the area we're talking about and showing the shadow of the moon passing along that path of totality, if you're in Florida or if you're in Seattle, you're going to see part of the sun covered up by the moon. If you're in Washington, D.C., it's going to be almost 90%. I think it's 89 point something percent. It's still going to be rather bright outside, so you never want to take those eclipse glasses off. But it's going to be quite spectacular when you look up there with your safety eye protection on, your eclipse glasses, and really marvel at that spectacular event. And so Lika mentioned that. in 600 million years, I think you said, we're not going to have total solar eclipses anymore. So get out and see this one.
Really. And as we are talking about all of this, of course, we can take ourselves to the path of totality. That doesn't mean that we can see it, because nature, earth, cloud might conspire and not give us a clear sky, and not all of us can be on airplanes, flying above the cloud band. So, Dave, I know that you have been doing all kinds of cool stuff with GeoCollaborate. It's really an amazing tool, and you have kind of created some special features for this eclipse. Would you kind of show us some of that?
Sure. Yeah, I'd like to do that. We are coming up on time too. We have about 10 to 15 minutes. We don't have to end exactly at 8 o'clock, but we do want to respect everybody's time. So what I'm going to do is I'm going to stop sharing my screen, but I'm going to start sharing a window here. And that window is GeoCollaborate. So hopefully you can see it now. Hopefully it's popped up. And Janine, Lika, thumbs up. You can see it. Okay.
Yes.
We see it. Yeah, and I just wanted to also chime in. There are several questions related to weather and cloud cover, so I'm glad to hear you're going to discuss that now. So so Dave, if you want to just address that, if what people can see, if there's some clouds, and is it better if it's 90% in clouds or 100%, and what they might see.
Sure, that's a great question. So let's get into talking about the weather a little bit here. This is GeoCollaborate. It's showing real-time weather on it, so you can see the big storm that's caused several tornadoes in Indiana along the Kentucky border today, and there's a severe threat well into Ohio. This storm is wrapping up and moving out. Okay, that's good news, because this path of totality is for next Monday. So what you see in GeoCollaborate is the radar data. We can pull out a menu here and see different layers of information we can pull out. And so this is being used by educators in classrooms. There's students that can access this and look at it, and we're going to give you the address so you can access it too. But I'm going to turn on what's called the NOAA daytime clouds, and we're going to take a look at what this looks like right now. So you can see that storm wrapping up, and you can see in Texas, I'll zoom down into Texas here. These are pretty much cumulus clouds. So they're the puffy ones that move in and out, and you can see an eclipse between them. When it's clear and dark like this, it's nice and clear for eclipse viewing. But when you get into different types of clouds, like higher clouds, or ones that are certainly producing rain, they are clouds. And look, see, this is getting a little darker now because the sun is setting, and we're just seeing the tops of the clouds illuminated, which is very cool, by the way. I'm going to turn off the visible clouds and show you the infrared clouds. You can see more temperature in the atmosphere. So clouds like this that are white and pretty solid, it's going to be very tough to see an eclipse through those. So if you see a percentage of cloud cover in any weather forecast, and watch your local broadcast meteorologists and the National Weather Service, they'll be giving you very accurate forecasts leading up to Monday, April 8th. Don't look at a forecast today and throw everything out the window when you get to Monday without looking at any updates. You want to get those updates. So when you see clouds that are like this, that are sort of higher or medium level and broken, that's still good eclipse watching weather. When you get into this sort of view, it's kind of a give and take of maybe some breaks in the clouds, or you might see the sun shining through the clouds just a little bit. But in this infrared image in GeoCollaborate, these are heavy storms. The bright clouds here, these are heavy storms. and likely that you won't see anything. And of course, if any precipitation is falling, you won't see that. But what I wanted to point out with GeoCollaborate here is that you see all these purple telescopes along the line. This is the Dynamic Eclipse Broadcast Initiative out of University of Southern Illinois. And they have web addresses in each one of these pop-out windows. And you can put that into a web browser, and I'm just doing this live right now. And you can see, this is, of course, not a real image. They're practicing with it now, but you'll see what the sun looks like on eclipse day. So you can highlight that web address and see the image underneath the shadow of the sun. So if you turn on the daytime cloud image, you will see the shadow of the moon moving across the path of totality. It's going to be quite spectacular. You can see it from 22,000 miles up where the GOES satellite is, and then you can click on these telescopes to see what it looks like from the ground up. So if you're not heading to the path of totality, you can sort of virtually experience the eclipse. It's not like being there in person, but at least it gives you something to look at. And there are some other projects here from NASA that you can access. Click on any of these links or these highlights on the map, and this will tell you what it looks like. There's also projects that are going on that you can perhaps get involved with from a citizen science perspective. And the address itself for GeoCollaborate, I'm going to put in the chat. So those of you that are hanging on in this webinar, or I'll put maybe in the, I don't know if you can see the chat or not. Maybe I'll put it in the Q&A here, and well, I can't enter anything into the Q&A. Well, maybe I will put it in the chat. I can put everyone. There we go.
Yeah, David, should work. And I just put a link as well to some citizen science opportunities through NASA too.
Great. Awesome. So I just put in the chat to everyone the GeoCollaborate dashboard, and you can access this exact same information. We'll be updating things in the key points window. You can click on the little videos called the coronal mass ejections, eclipses in the future, and you can get a little tutorial video for how to use the dashboard. But we also have weather alerts. So if there are weather alerts in effect by the National Weather Service, it will light up the map just like this. We have severe weather going on right now in Kentucky and Indiana and Ohio, from flash flood warnings to these yellow dots here. You can click on those and see what that bulletin is. This is a flash flooding is caused by excessive rainfall, continues to be possible. This is a flash flood watch. And so you can interactively click on any of this. The reason why we're doing
so I was going to say, so you can see,
exactly.
I mean, America has the eclipse to watch, but weather can spoil the show. And I put the responsibility on our science, not heliophysics. We will have an eclipse if you can get yourself out above the cloud bank.
That's right. You will be able to see it from the WB-57. I think there are some airlines that are selling tickets to fly along the path of totality. But this kind of interactivity and this kind of map will allow you to dive in. As a matter of fact,
this is awesome.
It's a NASA-funded project where they're going to be releasing balloons, right, Lika? They're going to be releasing balloons into the atmosphere as the totality passes over, so we can see and take profiles of the atmosphere.
1 hour is not enough because we are almost on the hour to describe all the cool things that's possible and happening. Some through NASA, some through NSF, all different agencies, private sector. 2017, I think, was a practice run, and we have perfected that. It is really incredible. So the ones who are online, I'm making an assumption that you are eclipse champions, admirers, and please go look at all of these various sort of data that exists and ways for you to participate and contribute through the citizen science component of it. But before we go, I would love to show that one beautiful video of how the radiation gets cut off, right, as the eclipse progresses. The insolation video, do you have that?
Yes, I do.
And so this kind of, this gives you an idea of, how the, the dimness that we experience, right? So people will often ask the question, what happens, if the eclipse is partial? So one thing, and you're seeing this brightness map, basically what happens, and you can see the scale on the right-hand side, essentially. So in any place where you're observing the eclipse, the changes in the ambient light are generally not noticeable until the sun is more than 95% covered by the moon. Remember that. And when it is totality, there are very palpable changes in the local environment, in the shadow of the eclipse. It produces kind of microclimates. It's very interesting. But during a total solar eclipse, the moon's shadow covers only a small fraction of the Earth. So the Earth still continues to receive at least sort of 92% of the amount of sunlight it receives without an eclipse. But under the shadow, all kinds of interesting phenomena are happening that Earth scientists study.
That's awesome. This is really incredible. And Lika, what I'd like to do, and I don't want to embarrass you, but I do want to have you recite this eclipse poem. And you don't have to do it live because you know what? We have a video of it. And for those of you that are sticking on for just the next few minutes, this is 5 minutes long, and then we're going to end this. And we're going to put the link to this in the chat. So those of you who see it can share it around to people. But it's a beautiful poem that's read by Lika. I think you were...
and written by a friend who I met during an eclipse.
Yeah. Well, let's just take a look.
The title of this poem is Elliptical Triangle. I would say an ode to the eclipse by Guy Betzel. The tide was stirring up the sea which lapped against the sand. The sand made up a sunny beach which lapped against the land. The land rose up to mountain peaks which lapped against the sky. The sky contained the moon whose laps elliptic caused the tides. I whispered to my girlfriend on the mountain by the sea, "Hey, can you keep a secret? The man in the moon is me. I like to shine upon you as I cycle round your world, for I can tell from far away you are such a far-out girl. I drive the sea and winds which move the rivers and the sand to sculpt a ring of canyons which I place upon your hand. I orbit round you, sweetie. You are my world, my number one. Whom would you cherish more?" My sweetheart answered me, "The sun." I bellowed, "The philanderer, you think the sun's so great? You think that you are his only girl? He has another 8. Oh, darling, I'm so faithful. Please consent to be my wife. For what can he provide that I cannot?" She answered, "Life. He offers food and light to the plants, with which I abound. He gives me thermal power, heating up my fertile ground, enabling my children to proliferate and spread. I love you, you big lunatic, but without him, I am dead. This answer left me speechless, mad with envy and chagrin. I spent my life orbiting her, and she's in love with him? I said, I'll win you over. Yes, I must, without a doubt. I'll show you who has the power. I will block your boyfriend out. Her voice was full of fear. Oh no, don't make him go away. My children need him to survive. They need the light of day. Oh, please don't do that, you propose. I heard her stricken cry. I need the sun, for as I said, without him I will die. I felt a pang of pity, but it quickly turned to glee. If I can pull this off, I thought, she'll be impressed with me. Then she'll know who holds the reins of power up above. And then with me, it's plain to see, she'll madly fall in love. I sat right down to work my plan to rule the sky. I worked out the equations of the paths that we three fly. I figured out a way to shift the track of my ellipse, then put my scheme in action and created an eclipse. I marveled at the beauty of the shadow on the land. I reveled in my glory that I had done what I had planned. And turning to my sweetheart, sure that now she would think me great, I saw her staring at me full of awe, but also hate. I realized at once that terror could not be the way to win her love, and so I moved, restoring full the day. She smiled, and it warmed me as the sun was warming her, and I knew that I was wrong to keep light from the earth. This happened centuries ago, and every year since then, for just a couple of minutes, I have blocked the sun again. A short reminder for the earth for whom my love still burns. To show her I accept that it's around the sun she turns. The tide, it still starts up the sea, which laps against the sand. The sand still makes a sunny beach, which laps against the land. The land still rises to the peak, which lap against the sky. And lapping between the sun and earth, eternally am I.
What a way to end this webinar. It's terrific. Thank you, Lika, for reading that poem. It's wonderful. I would hope that all of you on this webinar get out and see the eclipse. I wish you clear skies. It's going to be tough, I think, in some areas, but other areas, I hope it is very successful for you. Make sure when you see the path of totality, you look down as well and the eclipse, because you'll see hundreds and hundreds of eclipses coming through the leaves, and you'll see them on the ground, and it's just fascinating. So get out and enjoy it. Have fun. And we hope that you enjoyed this webinar from the AMS Weather Band. And Eric, I'm going to throw it back to you. Thank you, everybody, for watching.
Thank you very much, Dave. Thank you, Dr. Hathakurta. Thank you, Janine, for a fantastic event. I think we're all getting ready for the eclipse. For everyone still here, if you want any of the links, we're going to have all of that available for you at amsweatherband.org. All links that we've shown here and the recording as well. And thank you all very much for joining us. Thank you for putting on a wonderful webinar. Have a great night.